Let me see our next presentation, which is uh, actually a mini workshop, is on eye tracking, delivered by Dr. Anahita Khorrami. Dr. Khorrami received her PhD in cognitive neuroscience in 2013 from the Institute of Cognitive Science. She is currently the director of the Utah Clinic and neuropsychological rehabilitation manager at the Brain and Cognition Clinic. Her research interests include cognitive science, social cognition, neuromarketing, and applications of modern technologies like eye tracking, TMS, and ERPs in cognitive studies. Today, she will be instructing this session's mini workshop entitled Introduction to Eye Tracking in Studies of Cognitive Science, Bridging Neurolinguistics and Cognitive Linguistics. Dr. Khorrami, we are
Hello.
pleased to have you. The stage is yours.
You can hear me?
Yes, we can, but we don't see you.
Let me. I thank you to invite me. I introduce me, Mr. And if you let me, I start with what I think eye tracking can teach us about language processing. I'm so happy with you, and I try to explain more about this instrument in view of language, and let me to extract some main points of this field because it's very expand, and we can talk about everything in this short time. If you want to start, I should say why. Why is eye tracking used in cognitive science? If I want to say this instrument is exactly for the language, is not extraordinary uh, um, that type of science that I can speak about this view of method in cognitive science. Why? I track it about the eye movement, and the language is not anything in reading except eye movement. In this regard, scan pattern give delayed information about the mental processes that are developing in a person's mind and reveal what visual information is going to be used by these processes. Eye tracking can have a role like fMRI. How is if I want to start to talk about this topic, I have to mention many details. But one thing that I can say, we can register many methodological instruments with each other, synchronize with each other, like eye tracking and electroencephalography, eye tracking and fMRI, eye tracking and EMG, eye tracking and face reader, eye tracking and JSON, and blah blah blah, so on. With this regard, if we synchronize eye tracking and fMRI, we can find different functional part of brain that process language. And we just with C2 on tracking, C2 blinking, C2 second, C2 uh, pew pew reaction, we can find the pathway, the brain pathway that guide us to language processing.
Excuse me, Dr. Khorrami, for
Yeah,
interruption. Is it possible for you to turn on your camera?
excuse me, I can't hear you. Is it possible?
Is it possible to turn on your webcam?
If the net lets me, please.
Okay, thank you.
I hope, let me,
Okay, if you have,
is okay?
okay, it's okay, thank you.
Okay, there are some components that we have to know in laboratory when we work with eye tracking. One of these parts that you should estimate and you should apply in a statistical part of your study is fixations. What is fixations? I just mentioned the reading part because we don't explain the whole part of eye tracking. It's very, very vast. Fixation, gaze stays fixed on one position. Fixation is the part of information processing of brain. If you have a saccade and eye movement, you can extract the information, the data from the environment and just fixation. When you stop your eyes on one part of space, you can your brain can find the information or the data and process it to information. In this regard, when you see these circle by circle, they are fixation. And if they are larger, they take more time. It shows that it taking more time. And the intake of new visual information. You change information through saccade, but you take information through fixation. And that's time to planning of new eye movement, where the eye should move to which side of the space. In this regard, you should know eye tracking extract the spatial samples, information in spatial samples of space or environment. Second, fast movement of both eyes in the same direction, left or right, up or down, circuit. Processing of new visual input is limited. Low spatial frequencies attenuated and high spatial frequencies unaffected. If you have high spatial frequencies, you have some information, you bring some information for the brain. But it's not the same for lower spatial frequency situation. And top velocity proportion to amplitude of the second. In this picture, you see these lines. They show second that link this fixation to the next fixation. Okay, one of things very important, sometimes difficult process of finding a target among distractors in often cluttered visual environment. Physical and cognitive processing limitation can prevent us from instantly recognizing the presence of a target item in a single glance. Large number of shade features with distractor or fuzzy target specification. What does it mean? Your control of attention. Eye tracking is for the eye movement. Eye tracking is for the visual information. It's designed for the visual information, not for other cognitive processes. But we have found that we can use it for evaluation attention. It's very important. Nowadays, we use it for attention, different types of attention. Two main type of attention that are bottom up and top down. We control of attention and we implicitly or involuntarily uh, change the direction of movement of eyes and it's out of our control. What happened to attention in view of eye tracking? When you say bottom up factors, drawing attention, it means the onset of information processing, visual processing. Immediately, your eyes find the feature that capture the attention. Top of this feature could be movement and or motion and colors, unique colors. Even when the location of the target is known, highly salient features that are known not to be associated with the target can still capture attention. Please take a look at these pictures. At once you find the left upper, among the X. Immediately you find the red X because the top feature is the prominent, the salience color. But if I require you to find the O, O has the different shape among the X. The second type of feature that could be immediately captured through the uh, eyes. But what happened between these two features? Color is the uh, top feature, more salient feature for the brain. For this regard, you can control your eyes. At a glance, eyes find the X red. Even I require you to find the O. But among the other X that are similar to each other, you can find the second eye in the second eye movement, the O. The low picture, what does it say? Please pay attention. In the top part, you can find T, different shape. Through the other shape, your eye take a short time to find the T. It's not very easy. But if the number of the T in the stationary picture increase, what happens? I find better. I find faster, faster and faster. But the lower part, moving, what happened to moving? Moving is a feature that take attention, that capture attention much faster than the stationary uh, situation. Okay, what we know about the top-down factor focused attention? Target specificity, the number of features the candidates share with the target, as I mentioned, and what your memory can find faster than other features. They are affect your attention, your eye movement, and samplize the environment or environment or space in front of your eyes. If I want to speak about the basic of eye tracking in psycholinguistics, and eye tracking in natural language processing, what we should know. I should mention here, eye tracking is an instrument with infrared camera. We can talk about it more about the details of instrument in a long workshop. But in a short thought, I just mentioned about what happened in reading, and you can design the task, your study, your thesis, and so on. Eye-tracking features, what you should know about reading. Please see this word. I changed. What? You can see this word, letter by letter. The eye tracking separate these parts, but in different language. First line of processing is the shape. Brain don't know anything about the language. Brain know many things about the symbols. And some part of language processing change this information to language. In this regard, S, I, G, R, they are vertical, opposite to Farsi letters. We should consider all these features, all these properties of language in our task design. We have somehow many problems in Farsi because we uh, don't have a main view about the studies, design of studies for the Farsi language. Okay, AI tracking separate these letters one by one and assess the fixation and second. What should we know here now? First, you should know when you take the information from the crew information from the eye tracking, you should extract first fixation duration. I talk about it more. Landing position, mean fixation duration, second from word to other word, and total reading time. Provide information on all levels of text processing. What we should know about psycholinguistic and research, reading research, please pay attention. Most of the studies in line of language dependent to neurolinguistics. Neurolinguistics could talk about the all language processing. Why? Why? Because in most studies they don't consider cognitive processing of language, and they just find the pathway, the neural pathway that they uh, that they can want to explain the language processing. It's very important to know more about cognitive processing, the link between language and cognitive processing. What does it mean? You should know about the executive control, you should know about the memory, you should know about the attention, because they are the fundamental function of the brain to information processing, for information processing. When we talk about the behavior, we and behavior processing or behavior assessment of language, we talk about the field of science called psycholinguistics. Online real-time methods of natural reading in an ecological valid experimental setup, we mean explain the psycholinguistic and reading research. Okay? Skipping behavior may indicate ease of processing. When you read some part of the sentence, some part of the paragraph, sometimes your eyes skip some words on some part of the sentence or paragraph. What does it mean? It means, in view of eye tracking, indicate ease of processing. Longer reading times may indicate confusion or difficulty. Longer regression may indicate difficulty in incorporating context. I explain more about the regression. This insight into cognitive processing affords learning behavior and engagement. Engagement means how long and how many times you can take your attention and control your attention or change your attention. That means engagement. How we use eye tracking in different fields of science of language, in medical, in literature, for language processing, reading, listening, all of them are suitable for eye tracking. For example, dyslexia and reading difficulties, improve education materials and learning processes, insight for reading naturally, taking into account individual difference, cross-linguistic difference, native speakers versus bilingual versus language learners, language-specific reading and comprehension characteristics, machine learning, predicting native language, predictive proficiencies, classifying text readability. All these parts very important and top study title of the world, and you can find in Science Web. But natural language processing is very, very, very important for the scientists. Why? In 2 points, we can mention why NLP is very important. One of them is that how computer can behave like human and can process language like human, and how human can understand the language machine, and they can make conversation with each other. In the field of this branch of science, the potential of eye tracking in LMP improving in NLP models, because eye tracking has ability, relatively easy to collect the information, existing data set in various language, readiness, behavior online metrics, and pre-processing required. Understanding NLP models, one is language model, cognitive plausible, psycholinguistics say if it exhibits similar processing patterns as human, as I mentioned, and NLP if it makes similar decision as human. Please consider that we have, when you read some part of words or paragraph or sentence, and when you listen to someone, and when you just see or take a look on word or words, it means your brain have a perspective, have a hollowness, and it's not just linear for linear processing. It's very important. Now we know that in language processing, brain make information in perspective view. Okay, it can make a window on mind and brain and reflect human text processing. How we can improve an NLP model with eye tracking data? First, multimodal models. What does it mean, multimodal? We can use eyes, our ears, our touch, and we can work and mix all this modality in one study. And this means learning from text and eye movement. During the worldwide corona, we found that many uh, schools use the eye tracking to follow their students, how they learn and what they learn, where they learn, and when they learn. It's very important for education, for improvement in education. In other view, multitask approach is one other uh, property of this field of science. Modest but consistent improvement on various levels of text processing. And what is the challenge in this study? Pre-processing decision. With eye tracking, we can't know anything about the pre-processing decision in the brain, because you just find the behavior. You can't talk about what happened before processing the language. That is the weakness of eye tracking. And we can solve it with the synchronize or register the different method like EEG or fMRI. Analyzing NLP models with eye tracking data. predicting human reading behavior method. Can computational language models predict human language processing signal? That's a big question. Correlating computational and human language processing. How well do the weights learned by computational language models correlate with the human patterns of language processing? That's the other big question. That may be useful for the university students that want to know what are the best questions in the field of language, especially for NLP models. Okay, if we want to summarize better understanding of the similarity and differences between human and machine language processing is the main question of NLP models. Some achievements in language processing and I mentioned here, they are very important when you want to design the task, the study, the thesis. They are very important, especially for English language. We don't know many things about Farsi. We have some study, but they are not consensus, or they are not in a line of one research that you can trust on the results. People do somehow read a text smoothly, not smoothly, but fixate a particular word 200 to 300 milliseconds and jump to the next. A jump or second, jump in second, direction, different direction of eye movement. Covers 7 to 9 letter space. It's not clear. It is okay for Farsi or not. We don't know. During a second, visual input is reduced, as I mentioned before. Second is not the behavior for the information taking. It's just for the change the spatial resolution or space or spatial attention. Readers skip short words and words that are highly predictable. These words are identified in the paraphobia region. I talk about paraphobia. Readers regress or look back. Readers often understood on written sweeps going from the end of a line to the next line. The perceptual span is asymmetrical to the right. It's acceptable for the language like English, but for us, unfortunately, world don't know anything about Farsi. They mention here the Hebrew language. That's paraphobia. If take a look to retina, back of your eyes, you can find a yellow part that is named or called macula. In the center of macula, it is a 1.5 millimeters fova, and around it you can find two 5 millimeter parts parafova. Now is about 3 4 years, language scientists and neurolinguistic scientists and psycholinguistic scientists and cognitive neurolinguistic scientists, they are Parfova is very, very important part of processing for these researchers. Why I mentioned it as it's very beautiful how we take the information from the words through our parfova, not fova. For the precision perception, for the precision attention, for precision seeing, looking, everything you call it, we need fova. But parafova find curiously the details of the data in the environment and pass it to the brain. I make an example, you can understand me. The other part of macula is pupil that is 5.5 millimeter around fova. And all of this part, this circle, is called macula. You can see here again, and you can find you'll see or you're looking to the world in this view. That's this small part, a small circle is for part of for, and this span of your eye spatial search. About 16-degree visual angle, one visual angle, and about 2 to 3 visual angle. What happened to typical leading in experiments? It's very interesting if you can follow me in this small study. If we have garden pet centers and in I should mention another thing here and remind you in a task design for each sample, for each target, for each question, and for each event, you need a control. In cognitive science, everything should be compared. You can't purely study on what you want, the target of your question. For example, here, what about garden path centers? Garden path centers are the syntheses that, in the meaning of the sentence or part of the sentence, is the ambiguity. For example, since J always jogs a mile seems like a short distance to him. The contour sentence is since J always jogs a mile, this seems like a short distance to him. What happened to this study? I extract the first sentence. Since they always jogs a mile seems like a short distance to him. And talk about that. Please pay attention here. You can find the fixation of the reader through the green circle. The first fixation is on the J, second always, third jogs, and so on. But when the readers go through the sentence, two seems she or he stops and take more time to processing the word seems. And you can see the larger circle. That means longer time. The other color, red, fixation after regression. What does it mean? It means reader can understand the sentence exactly. She or he regressed to mind and process again and read again. In this regard, she continue with fixation after progressive second pass. This part is first pass, the green. This part is fixation after regressive second, the red, just one fixation, and this part is fixation after progressive second, the second pass. What does it mean? Here is a difficulty. What something happens here? Maybe we can't find the meaning of sentence. If reader experiences some sort of trooper, they may fixate the difficult region longer and they may even regress to earlier parts of the sentence or text. How do we interpret the reading pattern? Now you know some components, some features of eye tracking. How do we interpret these components? What does it mean, these different measures? First fixation duration means duration of first fixation in a region. First pass duration time spent in a region before moving on or looking back. Regression path duration time from first entering a region until moving the eyes beyond the region includes regression time. Second pass duration of refixation. Total duration means the sum of all fixation in the region. And the other component of measure probability of regression, the percentage of regressive eye movement out of a region. We review this part to interpret because it is very more important for eye tracking. Eye tracking seems easy instrument, but really it is very difficult, especially the interpretation of the measurement or components. They are very difficult. For example, in this sentence, you can find Bart annoyed Homer because in this sentence, the target for the researcher was Homer, not Bart, not annoyed, not because. They wanted to know what happened to Homer. Let me to see what happened to Homer. You can find the first fixation on the Bart, second fixation on the annoyed, third fixation on the Homer, and four on the Homer. But what happened to five and six? When you see five, that means on the Homer, the reader had a regression and regressed to annoyed. That means the regression pass. You can find here first fixation duration to number three because Homer is the target, not Bot. Here, first fixation is three, not one. First pass duration, 3 plus 4. Regression path duration, 3 plus 4 and 5. Second pass duration, 6. And total duration, 3, 4, and 6. I hope you can understand what happened for the measurement or components of eye tracking and how we interpret them. It means when you talk about total duration, these three fixations important. When you talk about regression path, 3, 4, and 5 are important. What should we know about the different first pass measures? Different first pass measures are very, very important. We can break it in different parts on different measurements: first pass fixation duration, first pass duration, and regression pass duration. They all have to be measured and interpreted when you talk about the reading a sentence. How do we interpret the reading times? Just and Carpenter 1980 had the I-mind assumption to explain how our mind process what happened to I when you read the sentence or text. They had a model. They explained that this include process like word recognition, syntactic parsing, and semantic integration, referential integration. Please let me show you eye tracking how to know you about this model. Van de Broek 2004 had an ideal model for this processing. He talked that if you have a word like Snow White, keys, A, not dependent to the letters of the meaning or complexity, or dwarf in a sentence, four words in a sentence. When I fixate on each word, your brain process all these steps of processing: word integration, parsing, semantic integration, referential integration. But it's not correct for real world. iTrack showed the real world is a real mess. For example, when you read a Snow White and you see a Snow White, your brain pass all the processing one by one, but parallel processing. It takes a time with different part of brain, and you can see in the fMRI separated all these processing for snowball. But what happened for keys? What happened for A? What happened for dwarf? It means you can find overlap of processing for keys, A and dwarf. You can when you read a sentence, your brain don't process each word one by one in different processing. All of this processing overlap. That means your brain have a perspective for the reading, have a hololens for the has a hololens for the reading. Your brain doesn't process one by one. They process all the sentence and overlap the processing of each the word. The real world is a real mess. In the real world, the processing of word is continuous while fixating word x plus 1 and possibly while fixating word x plus 2 and etc. Thus, the effect of the manipulation are often visible more downstream after the critical word or region is called spillover. Spillover is very important in language processing. It means in reading, gaze towards longer on a word that occurs in frequency in English text, low frequency, than on a more frequent word, high frequency, but also on the following word, which is referred to as spillover. What happened to development? Eye-tracking is a very important instrument for study in development or developing processing of language or in childhood, in infant. The study of language development is no exception. Language is a hugely complex system whose development is affected by many factors, including both cognitive factors such as processing efficiency, statistical learning, phonological awareness, and environmental factors like the socio-economic status of the child's family, the quantity and quality of language heard by the child, and the number of people with whom a child regularly spends time. Okay, we need a method to converge all these features and that can specify what happened for the child, for an infant when they try to speak the first word, or we can study this process in phonological view. Model for early language development is a strong need to move to a more efficient data collection methodology coupled with stronger statistical models. Combinations of sophisticated technology to allow researchers to examine the language environment as well as those cognitive processes influenced by and influencing language environment, equal to systemic approach to studying language development.
Excuse me,
Eye
Dr.
track.
Khorrami, for
Yeah.
interruption. You
The
have
time over?
5 minutes left.
Ah, okay. Eyetracking and language environment analysis that I call the LENA, automated language processing in examining language processing, where language processing defined as how quickly and efficiently an environment attach a word to its referent. This is sometimes referred to as real-time word recognition or comprehension. Okay, I have limited time. I try to talk about a little about this study that my student Razi Feizabadi study on assessment of pattern of reading of literature story through eye tracking. I want to mention some um, trick in the study of such in the such design of the study is very important. Uh, Excuse me, that's Farsi because the disease was Farsi. Uh, we chose we chose a story. In Farsi, we called it Bachahay Nime Shab, and we found that in Poland they studied on uh, 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 this story through eye tracking. They wanted to find the pattern of reading between two groups of people who are experienced in reading the story and who are not experienced in reading the story. One part of this method was very, very difficult, and that's how you deliteralize the literature, the story, and how you match the control and the target. I wanted to talk about that more, but if you have questions, I mentioned when I answer you. And another study I want to talk as model of reading is to see. I mentioned to you that reading is a special process. I want to show you what is exactly spatial processing, spatial sampling. We work on the learning disorder, dyslexia, Nilufar Tabande, my student, through eye tracking and use land notes and compare with the Farsi sentences. What is land note and how we compare that? Please take a look at on the original text that um that we chose this study to design our thesis. The original text is the upper text, and the middle is the literal translation, and the lower land node stimuli. What is mean land node stimuli? Please take a look on in. You can find two O here. It is important in language processing model that cognitive neuroscientists uh, believe each word have a space, not just you before you process the letters, you process the special part. You process the size. For example, the morning with which is other. This is this part. One, two, three, four, five, and six. Oh. When you see two here, that's this part. Land node is some symbols in psychophysics psychophysics method that let you to know more about the spatial processing far from language processing and more know about the symbolizing how your brain symbolize the language and how your brain pre-process the language before your brain make sense of the different part of these symbols. I finished this part with this study, and if you have questions, and if there is more time, I'll talk about the models.
Thank you very much, Dr.
And thank
Khorrami,
you, and thank you
for
all for
your
the audience.
presence and your great presentation. Thank
Thank
you.
you again, and bye.